Welcome back to another lesson on trigonometry. In our recent studies, we've seen how the law of cosines can give us 1, 2, or even 0 solutions to the triangle problem, depending on what we are given as inputs. Let's look at another problematic case that yields 0 solutions. Remember our 4, 5, 6 triangle from the first case. Let me replicate it here on the board. For ease of visibility, I'm going to scale it up by 2. So instead of 6 inches, it'll be 12 inches at the base. Now, if this side length was 4, I will scale it by 2 to 8 inches on my compass. And likewise, with the 5-inch side, I will scale it by 2 to 10 inches on my compass. Note the two arcs. Where they intersect is my unique solution to the 4, 5, 6 triangle. Now I'll simply connect the points with a straight edge. And clean up a bit. That is how to construct a triangle given a compass and a straight edge. In this case, ours is 4, 5, 6. Now if you missed our first video, we used the law of cosines to find the interior angles. What if instead of a 4, 5, 6, I had a 2, 3, 6 triangle, and I wanted to plug that into my law of cosines? If this is the angle I want to find, corresponding to angle B on my generic triangle, notice how I've rearranged the terms in the law of cosines such that B now shows up in the equation. The thing that's important is to make sure capital letter B is in cosine and lowercase b is on the left-hand side of the equal sign. Now I simply fill in the numbers. So following through the work, I come to the point that cosine B is equal to negative 23 over 12. Or, written as a decimal, cosine B is equal to negative 1.91666666, repeating. How do we find angle B? Well, we take the inverse cosine of both sides. Go ahead, plug this into your calculator, see what it spits out. Take the inverse cosine of negative 1.91666666. You should have gotten an error message. Now let's think, why is that? Remember back to our unit circle. The radius of the unit circle is equal to 1, meaning cosine, and sine for that matter, is bounded between positive 1 and negative 1. Negative 1.9 is outside those bounds. Therefore, we are getting an error message when it comes to the angle. Now, many of you probably noticed this right away. A 2, 3, 6 triangle is an impossible triangle. Why is that? If I set my compass to 2 units and draw an arc, and likewise set my compass to 3 units and draw an arc from this point, where do the two arcs intersect? Well, they don't, because 2 plus 3 is equal to 5. And 5 is shorter than 6. Therefore, there's no way we can make a triangle out of side lengths 2, 3, and 6. Because it's an impossible triangle to construct, we get an error message when we plug it into the law of cosines. Now I chose angle B. You could have run it with angle A or angle C and run into a similar result in which you get an error message on your calculator. Feel free to try this on your own and let me know what you find out.